I want you to picture something for a second. You're stepping onto a busy downtown street.
Right in the middle of rush hour.
Exactly.
Yeah.
The noise of the city is just all around you. You hear engines idling aggressively, sirens wailing somewhere in the distance, maybe delivery trucks rattling over potholes.
Typical city chaos.
Yeah. And maybe you're holding a child's hand tightly. Or perhaps you're watching an elderly citizen move carefully, cane in hand, across the painted white lines of the intersection.
Taking their time.
You step off the curb, entirely trusting that the glowing green walking figure across the street is going to protect you.
Right, from the thousands of pounds of moving metal just a few feet away.
You completely trust the system. But what if I told you that the system, for all intents and purposes, doesn't even know you're there?
It's a sobering reality of urban design, honestly. We walk around assuming the city sees us.
That the infrastructure is actively managing our safety.
Right. But the actual mechanics of most intersections are completely blind to human beings.
And that is the mission of today's deep dive. We are uncovering how cities are trying to fix this massive, almost unbelievable blind spot in urban planning.
It really is a massive blind spot.
The cold, hard fact is that current traffic systems are built for cars. They optimize for vehicle throughput.
Which leaves pedestrians, the absolute most vulnerable people on the road, effectively invisible.
Invisible to the very systems supposed to protect them. So, to explore how we fix this, we are looking at a fascinating project challenge proposal today. It's titled Smart Pedestrian Safety, the Favoriot Insight Framework.
And this document is critical because it forces us to confront a fundamental flaw in how our modern intersections operate.
The core problem statement here, the thing that really got me, is that our traffic lights currently operate on fixed timers.
Right. They just count down.
They just count down. They rely entirely on historical assumptions, not real-time evidence. The system assumes a crossing takes 20 seconds.
It assumes no one is still in the crosswalk when the light turns red.
Yeah, and it assumes there isn't some massive crowd of commuters suddenly waiting to cross because a train just let out.
That lack of real-time awareness is exactly why this matters to anyone who walks in a city. Think about high pedestrian density areas.
Like transport hubs.
Transport hubs, busy school zones, bustling commercial districts. Despite the sheer volume of people navigating these spaces, city authorities rarely know when a sudden crowd forms on a corner.
They just don't have the data.
They don't know when someone decides to jaywalk. And they certainly don't know if a person slips on some ice, falls, or collapses right in the middle of a crosswalk.
Which is terrifying.
As the proposal points out, without that visibility, cities simply cannot respond early to emergencies or make long-term planning decisions based on actual observed evidence.
Okay, let's unpack this. Because the Favoriot Insight Framework, which we'll just call the FIF from here on out, isn't just a document complaining about the problem.
No, not at all.
It is a comprehensive blueprint to transform this passive, blind monitoring into an intelligent, data-driven safety zone. And it does this through a series of analytical layers.
Right, starting from the ground up.
The foundation of all of this begins with what they call Layer 0 and Layer 1. This is all about making the invisible visible.
Layer 0 in the framework is defined as intent and context.
Intent and context.
Right, because before any city can apply millions of dollars of technology to an intersection, they have to define the specific human behaviors and risks they are actually trying to solve.
We need a target.
Exactly. The framework identifies several core safety risks that currently go completely unmonitored. We're talking about pedestrian vehicle conflicts, incredibly crowded crossings during peak commuting hours,
Jaywalking on those dangerous multi-lane roads,
slips and falls, and slow-moving pedestrians who find themselves trapped in the intersection when the light suddenly changes. Which leads to a critical thinking question for you listening right now. How can city planners meaningfully improve pedestrian safety if they can't even answer the most basic question? Like, how many people are waiting to cross a specific street right now?
You just can't fix what you can't measure. Which brings us to Layer 1, the data foundation. I love this part.
It's the technical groundwork.
Yeah, this is where the Favoriot platform steps in to gather real-world data and establish continuous awareness of the street level. But wait, if the current system is totally blind, how exactly are we giving the intersection eyes?
That's the big question.
Are we just throwing up a bunch of CCTVs everywhere and paying people to watch screens?
Not at all. Standard CCTV is essentially a post-incident tool.
Right. Someone reviews the tape after an accident has already happened.
Exactly. The Favorite framework outlines two distinct proactive types of data collection. First, you have video analytics cameras.
And these are smart cameras.
Very smart. They're equipped with machine vision. They don't just record video, they interpret it.
So they can actually detect human presence.
They literally count the number of people waiting at a crossing in real time. They measure how fast those people are walking and instantly detect sudden changes in elevation.
Which would indicate someone slipping or falling.
Or collapsing, right.
That covers the visual aspect, but the source also notes a second part of this data foundation involving IoT sensors.
The hardware side of things.
Yeah, and it mentions these can be used optionally where it is cost-effective. But the hardware described is just fascinating. We are talking about pressure sensors embedded right into the surface of the crosswalk.
So the street itself can literally feel your footsteps.
It feels you walking. They also use infrared sensors for detecting body heat, radar sensors to track the speed and direction of motion.
And environmental sensors.
Right, to monitor weather conditions that might affect safety, like heavy rain or black ice.
But gathering the data is one challenge. Transmitting it is another entirely.
Because it's a lot of data.
A massive amount. The technical infrastructure supporting this operation is vital. All of this heavy data from the cameras and the sensors has to reach the Favoriot platform quickly, securely, and without crashing the city's network.
The framework mentions the data is securely ingested using standard IoT communication protocols.
Yeah.
It specifically mentions MQTT and HTTP.
Right.
Those are pretty dense technical acronyms.
Right.
How does that actually function on a city street?
It's really all about efficiency. HTTP is standard web traffic, but MQTT is a lightweight messaging protocol designed specifically for devices with limited bandwidth.
Okay.
It allows these street-level sensors to send constant, tiny pulses of data, like a digital heartbeat.
Even if the local cellular network is heavily congested.
Exactly. Additionally, the framework utilizes edge gateways, instead of streaming massive, raw 4K video files back to a central server.
Which would just jam up the whole system.
Right. The cameras process the video on site, right there at the intersection. They analyze the footage locally and only send the critical data points back to the server.
Like saying 50 people waiting or one person fell.
Exactly. Just the insights, not the raw video.
I love thinking about this with an analogy. The old system, the one we have right now in most cities, is basically a blind metronome.
A blind metronome. I like that.
Yeah, it just goes tick, 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 change light. Tick, 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 change light.
It has no idea what's actually happening around it.
It doesn't care if there's a parade happening or if the street is completely empty at 3 in the morning. But this new data foundation acts as the city's actual eyes and nervous system.
It feels the pressure on the street.
It sees the crowd building up. It knows the weather is freezing. It is alive to the reality of the intersection.
Moving from a mechanical rhythm to an organic, responsive system is the ultimate goal here. But gathering all this raw data points us to the next hurdle. Layers 2 and 3 of the Favoriot Insight framework shift the focus.
Right, from just gathering data to actually understanding it.
Understanding what is happening, and more importantly, why it is happening.
Let's look at layer 2 first, which they call descriptive insights. This is the what. I want to explore what city operators actually see when they look at these Favoriot dashboards.
Because it's not just a matrix-style wall of scrolling numbers.
Right, it's a real-time pulse of the city's pedestrian activity. Operators see real-time pedestrian counts at specific intersections.
They see average crossing durations.
Literally calculating how long it takes the average person to get from one curb to the other at, say, 5th and Main.
And they can see the exact percentage of pedestrians who are crossing on the green signals versus the red.
Plus, they get crosswalk congestion alerts when a crowd exceeds the physical space of the sidewalk.
What's fascinating here is that this gives municipal authorities clear, quantifiable visibility into previously unrecorded events. Consider the safety monitoring aspect.
The slips and falls.
Exactly. The dashboard actually tracks exactly how many slips or falls happen at a specific intersection over a given month.
Because historically, unless a slip resulted in an ambulance being called and a police report being filed, the city had zero record that a particular crosswalk was dangerously slippery.
They were totally blind to it. Now they have an exact, undeniable count.
So what does this all mean? Having a shiny dashboard is great. But if the dashboard just tells a city planner that 50 people fell at a specific corner last week?
Or that 300 people jaywalked?
Right. That doesn't actually solve the problem. It just points out that a problem exists.
And that brings us to layer 3, diagnostic insights, which is essentially the system playing detective.
The why.
Exactly. Layer 3 is where the framework performs cross-sensor and behavior pattern analysis. Instead of just highlighting a problem on a dashboard, the system is designed to find the root cause by correlating different streams of data.
A crucial example from the source material is how the system correlates jaywalking rates with unusually long signal waiting times.
But wait, think about that for a second. How does a camera or a pressure sensor know the difference between someone jaywalking out of deep frustration with the infrastructure versus someone just stepping off the curb a few seconds early to avoid a puddle?
Right. How does it know the intent?
It comes down to macro-level data correlation. The system compares the pedestrian density data with the traffic signal duration data.
Okay.
If the system observes that a crowd consistently builds to an uncomfortable density, and the wait time for the crossing signal is 3 minutes long,
Which is an eternity when you're standing on a corner.
and the jaywalking spikes precisely at the 2.5-minute mark of that wait, the algorithm identifies the friction point.
Wow.
It proves statistically that the long wait time is causing the dangerous behavior.
Because the traditional assumption by a traffic cop might just be that pedestrians in that neighborhood are reckless.
But the data reveals the truth. Bad infrastructure is causing bad behavior.
It is absolutely amazing how the data connects pedestrian density with traffic signal duration to spot where vehicles and pedestrians are constantly conflicting. It's finding the invisible friction points in the city that human observers might totally miss.
Simply because a human planner standing on a corner with a clipboard can't process that much historical, environmental, and real-time data simultaneously.
They just can't.
The framework also links other seemingly unrelated patterns. It can prove a correlation between an increase in falls and specific rainy weather conditions at a certain intersection.
Which would indicate a drainage or surface material issue.
Or it can identify slow crossing patterns specifically localized in districts with higher elderly populations, proving that the standard 20-second countdown timer is wholly inadequate for that specific neighborhood.
Here's where it gets really interesting, because understanding the past and diagnosing the present is one thing. But layer 4 of the framework introduces predictive insights.
Anticipating the future.
Yes, anticipating future risks.
The system utilizes the massive troves of historical data and behavioral trends it has gathered to forecast potential safety risks before they even materialize on the street.
It sounds a bit like a traffic weather forecast.
That is a highly accurate way to look at it. Because the system has learned the daily and weekly rhythms of the city, the predictive models can forecast crowd buildups near transport hubs or event spaces during peak commuting hours.
So before the train even arrives, it knows the corner will be packed.
Exactly. It can estimate the likelihood of jaywalking at specific intersections before the crowd even reaches the corner.
That's wild.
It anticipates congestion at pedestrian crossings based on a complex web of time of day, current weather forecasts, and historical patterns.
The early warning system aspect of this is massive, alerting operators when a crowd size is just starting to approach dangerous levels.
Right.
Or predicting potential pedestrian vehicle conflicts so traffic patterns can be adjusted in advance.
It's entirely proactive.
But that brings us to the ultimate question for you, the listener, navigating these streets. How does this actually change your daily commute? How does this invisible web of data actually protect you when you step off the curb holding your morning coffee?
That is layer 5, prescriptive insights.
Turning insight into action.
Exactly. This is where the framework turns all of this predictive intelligence into concrete action. Layer 5 is about operational decisions, and the framework categorizes these decisions along 2 distinct timelines.
Immediate interventions and long-term planning.
Let's start with the immediate operational side. The system enables dynamic, smart traffic control.
Okay, what does that look like on the street?
Say the edge cameras and sensors detect a particularly large crowd waiting to cross after a concert lets out. Or if they detect a slow-moving person who is only halfway across the street when the pedestrian light is about to turn red,
The system can intervene.
it can communicate directly with the traffic light and automatically extend the pedestrian crossing time.
But if the system just automatically extends the pedestrian light every time someone is walking slowly, doesn't that risk backing up vehicle traffic for miles and creating a massive gridlock situation?
It requires a delicate balance. And that is why the system doesn't just freeze cars indefinitely. It optimizes the flow.
It negotiates between the two.
Right. It might hold the light for an extra 5 seconds to let the pedestrian clear the intersection safely, and then adjust the downstream traffic lights to compensate for the delay.
So the cars still get through efficiently, just slightly adjusted.
Exactly. And the system can also take other immediate actions. It can instantly dispatch emergency medical services if a severe fall or collapse is detected.
Instead of waiting for a bystander to call it in.
Or it can trigger safety alerts to local enforcement teams if highly dangerous jaywalking is occurring across a busy multi-lane road at a specific moment.
And beyond those immediate split-second decisions, there are the long-term urban planning improvements. Cities can finally use real, hard, behavioral data to redesign high-risk intersections from the ground up.
If the diagnostic data proves an intersection is fundamentally flawed, say, the data shows that pedestrians consistently only make it halfway across a wide boulevard before the light changes.
City planners can use that prescriptive insight to install a physical pedestrian island in the middle of the road.
They can install additional mid-block pedestrian signals where the data shows people are naturally trying to cross anyway.
They can improve crosswalk lighting and visibility, where the environmental sensors show it is routinely too dark for the cameras, and more importantly, drivers, to see clearly.
It takes all the guesswork out of pouring concrete.
But there is a vital operational detail here. Who is actually making these final calls? Is an AI just autonomously redesigning city streets and dispatching ambulances?
The source document makes a key philosophical point regarding these prescriptive actions. Human decision makers remain firmly in control.
Okay, that's reassuring.
The Favoriot Insight framework is not an autonomous agent taking over the city's infrastructure. Rather, it provides the deep correlated intelligence needed for human operators, traffic engineers, and emergency responders to act quickly, accurately, and with justification.
It empowers the city planners.
Yeah.
It doesn't replace them.
Exactly.
It gives them the evidence they need to secure funding for safety improvements that they might have suspected were necessary, but just couldn't mathematically prove.
It's a proof they've always needed.
As we wrap up this journey through the Favoriot Insight framework, let's summarize the overall impact. We are looking at a system that graduates a city from mere passive observation to deep diagnostic understanding.
Moving from reacting to tragic accidents to predicting issues and taking concrete preventative action.
The core impacts outlined in the source are significant. Drastically faster incident detection, a much more balanced movement between vehicles and people, and infrastructure that is built on the reality of human behavior.
If we connect this to another picture, it reiterates the powerful conclusion of the source document. A truly smart city must do much more than just move vehicles around efficiently to reduce commute times.
It has a fundamental obligation to build streets that actively care about people.
Pedestrians are the most vulnerable road users out there, completely exposed to the elements in traffic. Yet historically, they have been the least monitored and the least protected by our urban systems.
Until now.
This framework represents a massive leap toward a safer, more responsive, and more human-centric urban environment.
I really want you to imagine your next walk through the city. The next time you step up to a crosswalk and push that little metal button, look up at the cameras mounted on the light poles. Look down at the pavement beneath your feet.
Think about all that data.
Think about the invisible data network that might be working behind the scenes at that very moment. Measuring the size of the crowd around you, sensing the pressure of your step, checking the weather, correlating your wait time, all to ensure the system gives you enough time to reach the other side safely.
It completely changes how you view a simple walk down the street. It turns a piece of concrete into a protective environment.
It changes the entire relationship between the citizen and the city.
It does. But this raises an important question, and it is something to mull over as we conclude.
Let's hear it.
If our crosswalks and intersections become intelligent enough to continuously monitor our behavior, predict our daily movements, track our walking speeds, and log our missteps to keep us perfectly safe.
Wait.
At what point does a protective smart city start to feel like an environment of constant surveillance? How much anonymity are you willing to trade for the perfect accident-free commute?
That is a heavy but vital question to leave you with as we look toward the future of urban design. Thank you so much for joining us on this deep dive into the unseen intelligence of our city streets. We loved unpacking the layers of this framework with you, and we will be back next time to explore another fascinating stack of sources. Stay curious.